Kushant, ask your friends to join.
Yes,
Kushant,
sir.
ask your friends to join.
Good morning, sir. Hello, sir.
Hello, Anna ma'am. Good morning. Divyanshu, how are you? Hello,
Fine, sir.
Divyanshu. Yeah, yeah.
Yes, sir. Anna madam, Vaibhav sir, good morning.
Good morning, Mukti ma'am. Good morning.
Just was checking that audio is
Yes,
fine.
yes. Yeah, it's absolutely fine. Thank you.
Oh, thank
Good morning, ma'am.
you. Yeah, ma'am. Good morning.
Good morning, ma'am. Good morning, sir.
Good morning, sir. All the students, please convey message to in your respective class groups.
Good morning, sir. Good morning, Atan. Good morning, Atan, sir. Sir, your mic is.
Very good morning, everybody.
Yes, sir. Vaibhav, sir.
Namaste, Atanu sir.
Namaste, sir.
Namaste, sir. Namaste, sir. It's a pleasure to see you, sir. And
Never got a chance to meet you in person when I was
Yeah,
there in Dayanand Sagar.
yes, sir. So kind of you, sir. It's a great help for our student community, sir. So
Absolutely. That's the whole
Our,
motivation behind it.
yes, sir. Thank you so much, sir. Thank you so much. And in fact, very much delighted that you are here, sir, and you are sharing your experience with our student community, sir. It's a great help to the society, sir. Thank you very much, sir.
Yes, I think there is that education employability gap which the students need to bridge, and especially given the pandemic situation that we have been and the effects and the disruptions that it has had on the learning process, right? I think we need to prepare our students so that they can contribute effectively to the workforce.
Yeah, and to the society as a whole and to the nation as well.
Absolutely.
They are the future of our country.
They have to, we have to understand that that this is where the new ideas are going to come from, and they are all in Bangalore. It's a startup place, right? You have new ideas, you have the venture capital, you have the risk-taking ability.
Yes, sir.
And this is where we need to really forge that idea of Atmanirbhar Bharat, of being able to create very hyper-local solutions, because there are problems aplenty all around.
Yeah. And make in India type of concepts.
Sir, we can start, sir. Vaibhav, sir, you can say.
One clarification from my side, we are having a lot of rain in the morning, so my internet connection is becoming a little unstable. So if you're not able to hear me at any point, please let me know as soon as possible, right?
Sure, sir. Sure. We will start. Anna ma'am, we'll start. Anna ma'am.
Yes, sir. We can start, sir.
Thank you.
Which one?
Good morning, one and all. Respected speaker of the webinar, Mr. Atanu Roy Chowdhury, our chairman, Dr. Vaibhav sir, all faculty members and students. So it is my pleasure to welcome you all for this webinar. So this is a series of webinars which we have planned, and of which this is the first in that particular series. So the topic is embedded innovations on IoT, and we have a very renowned speaker for today's event, Mr. Atanu Roy Chowdhury, who is an IoT evangelist and founder of Capsule Labs. So I now request Dr. Vaibhav sir to address the gathering.
My dear students, welcome to this. My dear students, good morning. Anna ma'am, I'm audible, no?
Yes, sir.
Yes.
Yeah. My dear students, good morning. I welcome you to this session by renowned speaker Atanu Roy Chowdhury. We'll be speaking about on IoT. Make the best use of this session, as the sir was also telling that you are the future of this country. We have to see that the dreams like Make in India and startup type of dreams are fulfilled, and for that reason we are calling Atanu Roy Chowdhury and a renowned speaker, those who have a hands-on experience, which they will share their experience with you, their industry experience with you, and what is happening what are the trends in the industries, what are the recent trends in the industries that they will be sharing with you, which you need to see that you are making the best use of all this lecture. And as a part of our curriculum, this is important that whenever you are going through some lectures, when you're going through some lectures and all these things, you need to prepare the reflection note and submit it to your subject teacher. So I also, as I was telling that I also like to thank Atanu Roy Chaudhary sir. In spite of his busy schedule, he had came here and he is enlightening our students on his experience in the industries. He will be telling what is the recent trends in the industries, and it will be very helpful for you. So, my dear student, make the best use of these ideas. As you are aware that we have a special initiatives and all these things, that is a mini project type of concept from the third semester itself. So make these ideas, make this whatever you're listening at, try to implement all this thing. And we are always there as a ecosystem, as a support system. We are always there to help you, my dear students. We are always there to help you so that your ideas can come into a reality. And ideas are not anybody's prerogative. Anybody can get an idea and they can implement that idea. And we have the experienced people, and we have industry support to see that your ideas, with a small tinkering with your ideas, can be converted into a product. Your ideas can be converted into a product. And my dear students, as you are aware that you have to do a final year project, you have to do a projects in the final year. So start building. It is not the project building is not a 6 month or like a you can build a project in a 6 month or 7 month or 8 month. You have to consistently put efforts in doing some project, and then only you can see that you can do a good project. And as industries also as industry also need people who are hands-on, students who are hands-on. They don't want to put their waste their time on training you and all. So they want some students who are having the already having the knowledge and all this, already have a prerequisite, so that they can directly work on some project. Gone are the days when students used to join a company and then they used to be on a probation period. These are gone. Now you have to be industry ready, and for that we have for that to share his knowledge, Mr. Atanu Roy Chaudhary is there. He is having a good experience into this particular domain, and this is a you can say this is a very hot domain. This is a very upcoming domain. IoT, embedded, and all these things are upcoming domains, and we are lucky that we are in the branch called Electronics and Communication Engineering. In fact, if you are in a computer science engineering, probably you may not be aware of the hardware part, but here you are aware. You can be aware both hardware as well as software. I won't take much of your time, and I will request Atanu Roy Chaudhary sir to take on the session, and please enlighten our, please share his experience in the IoT industries with our students. Thank you, Anna madam. Thank you, Atanu sir, for your kind support.
Thank you, sir, for the inaugural address. I now request Mukti ma'am to introduce the speaker to the gathering.
Very good morning to everyone present here. Myself, Mukti Chaturvedi. I welcome you all to this session on embedded innovation on Internet of Things. Today, to give us application-based exposures on IoT advancements, we have with us Mr. Atanu Roy Chaudhary. Mr. Chaudhary is the founder of Capsule Labs. He is the technology mentor for Ranmeer Foundation, focusing on innovations, and is also a teaching faculty for innovation and entrepreneurship at Calcutta University. He has published over 35 papers and has patents in the area of IoT and wireless sensor networks. We are all glad for this opportunity of hearing from you, sir. Request you to now take over the session. Thank you.
Thank you, Chairman sir and Mukti madam. Right.
Thank you so much, sir.
For the welcome speech. Right. So without further ado, I'll get started. I see there's already 100 people, so we are kind of reaching max capability there. Right. Before I get started, I want to set out a few ground rules, if you will. Just a second. There we go. Yeah, so I wanted to send out a few ground rules before we get started. First of all, this is meant to be an interactive session, right? So speaking out your questions, please type them in the chat box. We will try to address them there, right? Unfortunately, I can take questions in probably Hindi and in English, right? But we will try to, we are all engineers. As long as we understand the specifications, we can communicate, right? So those are the ground rules. And today's talk is really broken down into 3 segments, if you will, right? In terms of what are the kind of applications of IoT, right? In in my mind, IoT is really a technology gateway, right? So pretty much anything that you can build on the technology side, whether it is in terms of embedded systems or in terms of cloud technology or web development technology or mobile app development or machine learning, all of those things, or blockchain for that matter, right? All of those things are getting integrated because we are building solutions in a different way. We are thinking about building these applications in a slightly different way, right? Just like the internet itself has been an enabler for e-commerce, for news portal, for journalism, for ticket bookings, for a wide variety of services to be provided. And, so has the Internet of Things, right? A few days ago, I was actually watching a talk by Steve Jobs, which was given around 1985, where he had mentioned that, you cannot change a person's boss every other day, right? You cannot change a person's reporting geography every other day, right? So organizations of the future, which will grow, which will scale, are going to be electronic organizations. Today we are seeing that, right? Today, if you look at a Uber, right, the driver partner is getting their instructions from a software, right? So the boss changes every time. You are connecting with different projects in different geographies, so you're not limited to the geography where you are working, right? So a lot of this is happening because the organizations themselves have become electronic, right? And we will continue to see that trend. We will continue to see more and more information being collected, being collected automatically, right? And that is where the Internet of Things is playing a huge role, right? And that's where the new opportunities as well are arising, right? So I'll start off with a video to get probably everybody a little excited. So that's the Dustin Farrell video. And the reason I wanted to share that particular video is because I think of IoT as new experiences, right? New experiences where, if you notice, there was essentially a synchronized lighting experience that was created with that AV that was there, right? And it's not a very elaborate. It's not a very, as a student project, this is something that can be done, right? It's not something that is super difficult to do, right? If you wanted to replicate this kind of an ambient lighting infrastructure, all you needed was probably a few things, some addressable RGB LEDs, right? A Raspberry Pi or any other capable embedded device which has an HDMI output, right? And you are using a software here called Hyperion, right? Hyperion, you can get a Hyperion pre-installed with a Raspbian image, and that's called a Hyperion image. You can run that. You can have an Android Hyperion ad, which will allow you to control the entire lighting experience and all of that. And that's about probably 6,000 rupees of investment, and you got yourself a completely new experience. Right? That's really the power, the wowing power of IoT, right? It allows you to build these kind of systems, right? But why should you care, right? Why should you care about this kind of a new experience? Well, let's go back a little bit in terms of the history of how we got here today, right? And what does it really mean for you, right? So if we look at how this whole thing came about, by the late 1980s, you had the personal computer essentially coming into the market, right? And people were, it was a big thing to have a computing device at your own disposal to do anything that you wanted. What could you do? Well, you could write some code. You could it was an advanced form of a calculator, right? You could start running a few spreadsheet calculations on top of that, right? So there were, but the fact that you are not using a mainframe, you are using a computing device itself, that's the first change in thought process that happened, right? And by the mid 1990s, you had the laptops that had come into the market. And with laptops, it meant it was just the computing infrastructure with its own power supply. But it meant that as a traveling salesman, as a corporate leader, right, you would have access to your data on the go. As a field engineer, as a field scientist, you could collect data from the field directly, right? So the time to make a decision was actually crunching, right? More so with the introduction of cell phones, that meant that you were reachable anywhere, right? So you had computation, you had your own independent power supply, and now you are starting to look at communication as well, right? That made decision making really, really simpler. Many of you would actually be amazed to know that the first IoT device, right, which was an internet-connected toaster, was actually made in 1989, right? And it was made before the first web page was created in 1991, right? Where the internet-connected toaster was actually working on a network on an SNMP-based protocol that was used to manage a lot of routers, right? So yeah, IoT has had a rich, long history, but things started to get very interesting after the 2000s when you had social media come into the market, right? And with social media, you were essentially blurring that line of when you are offline and when you are online. You are always connected, right? And the concept that a device is always connected, you could always get to know what your friends were doing, right? That was an innovation in itself, right? Getting more and more people hooked on, more and more devices always hooked on to the internet, right? And by 2010, you had your smartphones, that there were big format phones. Large screen was actually dedicated for accessing the internet, right? You had WebView, you had all these app stores that were coming up, right? Day before yesterday, Apple launched the iPhone 13, right? So 13 years back, they launched the first Apple phone, the first iPhone. And that would put us into the same time frame, 2007, 2008-ish time frame, right? This had a revolutionary effect because companies no longer needed all that capital investment in order to build an organization. They could now reach 1 billion people, 2 billion people 2.5, 3 billion people just by building an app and the relevant services, right? On the service side as well, our expectation from those services started to change significantly, right? Maybe 10 years ago, you would be very, very comfortable in when you were probably, you called a restaurant and you said that, hey, I want to, take this order, I'll come and pick it up and pay, right? Now you are no longer satisfied with that level of service. Now you want to know that, well, you have placed your order, your pizza's gone into the oven, right? Somebody's made your pizza, somebody has put it into the oven, a delivery partner has been assigned, they are on their way to pick up the pizza, they have picked up the pizza, they are now coming towards your home, they are 5 kilometers away, 4 kilometers away, 2 kilometers away. That is the level of data that we are now consuming, right? We want data at such fine granularity. That has fundamentally changed. And you would not be able to produce that kind of data had it not been for, essentially something like a GPS system that is there on the delivery partner's phone, right? The delivery partner would not have been able to locate either, where your home was or the pickup point was had they not had the app, right? So you're seeing this convergence of hardware, of sensors, of applications, of people coming together for this new kind of solutions, right? Nowhere more than, you're all in Bangalore, nowhere more than the smart cities that are getting created, right? Smart cities which are being enabled by government policy, right? Policies like, the UPI, right? The cashless payment infrastructure that is available, right? Aadhaar, the digital identity platform that we have, right? The GST, right? The taxation platforms that we have, right? So there are multiple platforms that have come together in order to to let us build on top of that and essentially allow cities to provide better services to its citizens, consumers to kind of improve their experiences by using these IoT-based solutions, right? But overall, you are all aware that today there is an exponential increase in the number of digital interactions because of two factors, right? One is there is more penetration, more and more people are using these services, and more people are using more and more of these services, right? So there are it's a twin effect that is going on, and that is what is creating this exponential increase in opportunities, right? Smart cities is definitely one place where IoT is getting adopted. Industrial internet is one area where IoT is getting adopted, right? So overall, you find that consumer electronics, enterprise IoT, in the medical field, in the precision farming area, right? So it's something that is pretty much penetrating every area, right? And one thing that we are seeing is that with smart cities, even electrical devices are being reimagined, right? With power conditioning, sensor integration, compute, and communication interfaces.
Safe, digitally savvy, and technologically accessible. That's why it's critical for cities to invest in infrastructure that makes smart living possible and sustainable. A smart city leverages digital technology to connect, protect, and enhance the lives of residents. The Internet of Things, or IoT, acts as a nervous system with sensors, video cameras, social media, and other inputs, providing the city operator and community with constant data and feedback so they can make better decisions. From smart lighting that helps keep city lights on, to digital crime fighting using facial recognition, to intelligent transportation and beyond, cities are clearly poised for modernization upgrades to become smart. These technology-driven solutions are redefining the business of running a city and have equal influence on how cities generate revenue, as well as how they own and manage assets. In fact, the potential benefits of digital transformation in cities are huge. Digital cities can generate $2.3 trillion globally through 2024. The deployment of these innovative new technologies can even provide a single pane of glass view of all of the community's data and cross-domain intelligence. This includes the capability to collect, aggregate, and refine data, then distribute it for faster response, improved decision-making, and more informed long-term planning efforts.
Right. Now, there are a few points I wanted to highlight over there, right? The amount of services that are being generated, right? And these are all, a lot of them are new services which do not exist today, right? But citizens may be willing to pay for that because it betters their lives, right? For example, in Bangalore, you have a very good urban transportation app that allows you to figure out where the public buses are, right? When is a bus going to your destination? When is it arriving at a particular bus stop, right? Even simple solutions like this, it helps save a lot of time, right? And with the smart city solutions, you're also seeing a lot of hardware being developed, a lot of control rooms being built out, and there are new job opportunities that are going to get created over here, right? So IoT is something where you have a lot of domain penetration, as I mentioned, in smart cities, Industry 4.0, enterprise IoT, consumer electronics, all of that, right? So IoT, if you look at it, is a lot of infrastructure, right? When I say infrastructure, there are these sensors and sensory devices which are capturing the field data, and then this data gets passed on using some on-site gateways to what we call our edge gateways, right? And then it crosses over into the IT systems where you have a cloud gateway getting the data into an application backend. The data is being stored, it has been sorted, it has been filtered, and then it is being represented in some ways, right? Where you're creating either a mobile app or a web app or some reports, right? So what this says is, unlike previous IT systems where most of the devices were, say, a Linux box, and you could essentially look at a pretty homogeneous operating system on which you are building the applications. With IoT, a number of these devices are heterogeneous. There's a diversity of devices, means that there are some devices with more sensing capability, there are some devices with better computation, some devices with less computation capability, some devices with less storage, some devices which are battery powered, some devices which are line powered, right? So you have a different range of a lot of diversity in the kind of devices that you are running, because of which you cannot run a uniform computational stack on all of these devices, right? Apart from that, IoT is not only new infrastructure, IoT is also a lot of new job opportunities. And that is why you should all be caring about it, right? Not only does IoT applications bring in have the regular IT jobs of backend development, front-end development, mobile app development, UI development, business analysis, right? All of these things are also there in IoT-based systems. But what is new is a set of new jobs where you have the semiconductor OEMs making new kinds of chipsets, right? Those chipsets are being designed, tested, and all of that. Those chipsets are being sold to device manufacturers who are integrating them into modules, into original equipment, making a packaging out of it, testing it out, selling it out for the retail market, right? There are field engineers who are required to go in and deploy these solutions, right? Whether it is a smart lighting solution or a smart traffic signaling solution, right? Those solutions have to be deployed and commissioned. The network has to be set up, right? The control rooms have to be managed. And that is where there's a lot of new opportunities for people coming in with electronics and communications backgrounds, particularly, right? Also from other areas, right? So that's where you should be particularly tuned into what are these kind of companies and what are the jobs that they are opening up in the market, right? So I will go into a little bit of a detail into how do you build this AIoT or this AI-based IoT devices, right? Over the next few slides. But any questions so far that I can take? Are there any questions on the chat window? None so far. No problems. We will move. Yeah, go ahead. Somebody had a question. Okay, we will move ahead, right? So how do you build this, what are called AIoT devices, right? Now, when you are building one of these applications, like you've all seen a legacy embedded device, right? I'm calling them a legacy with no disrespect, because we have all seen microcontroller boards. We have seen various kinds of motherboards that are available, and most of these systems have had, they have been self-contained, right? They have had their own. You see a little display module over here. There are a bunch of peripherals that are integrated, and mostly you would expect them to be running either on an RTOS-based system, or having some bare metal, or maybe some hardware abstraction layer at most, right? Some of them do have operating systems running on them, but let's look at what else is available, right? And most of the functionalities that this code running on these embedded devices is fulfilling is it's got a lot of this low-level functionality: interrupt handling, timer management, process management, IO management, right? Chances are you'll not have a file system there, so you might have to do your own page management. You might have to run your populate the display buffer yourself, right? So a lot of low-level functionality that is encompassed in the embedded OS that you have over there, right? And it is about managing a lot of these peripherals, right? Whether it is through interrupts or through GPIO pins, or it is analog or parallel, right? You also have some of the more synchronous serial protocols that are available to integrate the peripherals, right? Including SPI, I2C, CAN, right? So you will find a lot of sensors that are integrated onto the embedded devices using one of these serial wire protocols, right? Sometimes they can be asynchronous as well, right? Protocols like UART, right? And over time, we have developed some more like RS-232 and RS-485, which addresses a particular problem for these embedded devices, is that the data in this embedded devices stays on the device, right? Now, if we had to move the data out of this device, that's where these protocols have started becoming very useful, right? So from a connectivity perspective, right? I wouldn't call it, you can call it IQ, or if you want to call it intelligence level, right? Whatever data is happening, it's an intelligent device when it comes to its local functionality, but its functionality is limited over there. The data stays in the device itself, right? And because the data is not going anywhere, nobody's able to use that data unless somebody goes and looks at the display over there. This data is not published anywhere else, right? So that's why I've put it at a 0 on my IQ meter. Now, note that I mentioned that there are these couple of asynchronous protocols. Now, they were developed primarily because if you wanted to stretch out the data from these devices out to out to other devices, what would happen is if you had an SPI or an I2C kind of a port, the clock, being synchronous means that it has to run a clock. And the moment you're running a clock, you're getting the data, there is a very high chance that your voltage will drop across a longer line. And you will start seeing a lot more errors if you try to stretch out these protocols over, say, 5 meters, 6 meters, that kind of a range, right? So the next problem that had to be solved is, what if we wanted to move the data from these embedded devices onto probably some kind of a controller, some kind of a historian where we are going to keep this data, right? And then use a system to kind of visualize the data from there, right? Whether it is a direct connection or there is essentially some kind of a daisy chaining or some mechanism to kind of chain a number of sensors together, right? The moment you have this chaining concept, you need addressability, right? It's not directly addressable anymore, right? You need a specific programmable address for each of these nodes, right? And several protocols have emerged over time, and these protocols have emerged because different people have found that same problem, right? For example, people who are making cars, they said, okay, all the sensors in the car needs to come together, and we need to see that data together in one place. So they found something called a car area network or a CAN bus protocol, right? BACnet was created primarily for building automation and controlling various kinds of HVAC and various kinds of devices that are used in a building environment, right? DALI was developed by the lighting industry when it needed to control, facade lighting or building-based lighting, right? Modbus, Profibus, HART, these are all again other protocols that have emerged either over a RS-232 or over a TCP-based network down the line, right? But basic intention has been that you get data from the device and you move the data onto a controlling device or a gateway device that is far away, right? Now, this has worked all the way from the 70s, 80s, 90s. This has been evolving over time. But what you realize is that this network is still rigid, right? This network, once you lay down the network, it is not, if you wanted to redo the network or if you wanted to change the plant, you would have to redo the entire wiring again, right? And that kind of is a limitation on these kind of networks. They do not scale as per your requirements, right? Without significant overhauls, right? Now, that's one thing that has happened. The other development that has been happening in parallel is that we have been making a lot of development with respect to MEMS technology, with VLSI technology, and we are able to now take advantage of the physical properties of silicon, right? So we are able to create hanging structures within the design itself, and these structures allow us to kind of create micro electromechanical structures that can be used as sensors, right? For example, you see this triaxial accelerometer from ADXL, so it's a company called Analog Devices, right? Very small form factor accelerometer, right? And this is possible because they are doing the whole thing with photolithography. So they're able to create a large volume of sensors at very low price point, to the extent that today every cell phone has an accelerometer that is inbuilt, right? Similarly, other sensors have also reduced in cost, and this is meeting the demand for scalability. Right? With that, what is happening is now, instead of just putting a purpose specific sensor onto one of these embedded devices, the cost of these other sensors have also come down. So we are seeing a number of redundant sensors that are placed inside these field boxes, right? Including sensors which are for monitoring tampering or monitoring essentially if somebody is moving them, right? So today most hard drives come with an accelerometer so that it can move the rotor away from the disk if it detects that it is under shock, right? So it's increased the overall richness of the data set that we are getting, right? But it also means that there is increased compute that has to be done, right? The network is still rigid, but it has significantly, instead of getting data from one sensor, I now have to collect data from multiple sensors. Maybe I need to run a little algorithm over there to extract out the relevant information from that data, right? So for example, I can have if I have a sensor which measures temperature in the 95 degrees Fahrenheit to 110 degrees Fahrenheit or 105 degrees Fahrenheit. Ideally, that would be a temperature sensor, right? But if I put a little bit of algorithm over there, right, and say that, yeah, the temperature has been over 98 point something, I can turn that into a fever detector, right? So, whereas a sensor will give you an output in the range it is calibrated for, a detector will give you a yes/no answer for the algorithm that is specified in it, right? So understand the difference between a temperature, clinical thermometer, and a fever detector. Similarly, other things can have multiple sensors, multi-sensory input that are being considered before you arrive at the data that you want to send out, right? The detector that you want to make. And you have a number of companies, and most of them will have an office in the Bangalore area, right? Which are operating on creating these sensor modules, which are building the computational modules, right, for these sensors, right? ST is in Noida, but you'll find Analog Devices, Xilinx, Texas TI, Cyprus, Red Pine I know is in Hyderabad, Cyprus I think is in Chennai, but you will find a lot of these companies in and around Bangalore, and they are looking for engineers on the VLSI side. They're looking for engineers on the device building side of it, right? So focus on these and try and see if there are job opportunities that would be relevant to you. Right? So far, we have this line over here, which means that this has been a wired communication. But as we move in the level of complexity, as the systems start to become more and more intelligent, this is getting replaced with wireless communication, right? This is being replaced with wireless communication because there are several benefits associated with wireless communication. And I kid you not, it is not one or two protocols that are available for this kind of wireless communication. There are several communications, there are several standards that have evolved, right from the next generation of Wi-Fi called Halo to the next generation of Bluetooth, NFC, and RFID, you name it. There is a different protocol that has been offered from all the different domains, right? And you have so many choices because with IoT-based systems, your problem statement changes. There are several things that you have to consider when you are choosing what kind of a wireless communication you should be using, right? What are these considerations? Well, first of all, you have range. How far does your device needs to talk, right? Because the more range you have, you need square the power in order to make that transmission, right? So range is expensive, right? And there are different ways of achieving that range. Do you need it to be a single hop range, or can you route the data, use multiple intermediate hops to get that range, right? For example, when you're using the internet, you are hitting a server in a Google server in the West Coast, and you're getting some data from that, which does not mean that you have a wire going all the way there, right? But your packet is getting routed, right? The information request is being handled, so you get the benefit of range without the power, without the power requirements of going very, very a long range, right? So you have to take into account how much routing can you do, right? Depending on which geography you want to operate in, you also need to choose the electromagnetic spectrum or the frequency you're going to be using, right? 2.4 gigahertz, we all know, is in the ISM band, free to use. A lot of the Wi-Fi routers are now coming in the 5 gigahertz range. But in order to get longer range, you'll also get a lot of sub-gigahertz radios, which are in the 833, 866 kind of 866 megahertz kind of range. There are restrictions depending on your applications. If you are building an application which is military grade in a particular country, then you may have the flexibility of using some of the reserved frequencies for the military usage in the country, or you may have permissions to use it in the GSM bands, right? So depending on the application you are considering, you may get some free frequencies. You may be able to trade off between the amount of data that you need to send and the kind of frequency you are allowed to use for that application, right? This also brings us to the power question, because some of these devices are going to be line powered, some of these devices are going to be battery powered, some of them are going to be renewable powered, right? For example, when you use your cell phone, pretty much you use it on the internet. It's pretty much connected throughout the day. You're playing your games on it. But with cell phones, there is a very particular usage pattern that we charge the cell phone every night or every other night, right? With IoT-based solutions, that may or may not be possible. In some cases, for example, if you are doing street light monitoring or street light control, the street light is an electric pole, so you have 24/7 access to electricity, right? To line power. You are not as constrained with power, right? Whereas if you want to do something where the sensors are deployed for forest fire management, where you will not have access to a lot of power, right? right? So completely depends on the application and the sensors that are sensory devices that are being used, right? Additionally, there is the bandwidth requirement. How much data do you need to send? Are you going to be sending video data, or are you going to be sending electric meter readings, right? Electric meter reading somebody is okay with if you're sending 2 bytes a month, or 2 bytes every 15 days, right? Whereas if you are doing a video transmission from surveillance cameras, then you need significant more bandwidth, right? Also, the funny part with IoT-based architectures is you can trade off in different ways, right? For example, I said with a camera, you need a lot of bandwidth. But what if your camera is for, say, for example, if you wanted to know if there is a vacant parking spot available, right? So you're monitoring, you have a 360-degree camera that kind of keeps track of, if there is a parking lot available. You can use object detection on the camera itself and just send back a number of free slots or number of occupied slots rather than doing a video transmission. So you can by increasing the computational capability on the end device, you can trade off the amount of bandwidth that you need, and in a sense trade off on the cost of your communication network, right? So that communication trade-offs are very much present with IoT-based solutions, right? Some applications will have directionality and triangulation, right? Which means where localization is becomes very important, right? For example, LoRa gives you a reasonable level of localization. Bluetooth beacons, right? They are used for indoor localization, so which means that you are essentially trying to get indoor location within the precision of maybe a few meters. So there are places where you do not need GPS or AGPS, assisted GPS kind of precision, right? You can work within a building with a reasonable amount of lower precision, and that's where the radios themselves are able to give you that directionality in their beams, right? From their antennas, and you can use that directionality to create localization, right? To create triangulation, and create a localization with respect to where the transmitters are located. Right? Then you have other considerations, like, for example, fan out and density, right? How many nodes needs to connect to the next level, right? When you are using a cell phone based connectivity, all the phones are connected to the nearest base station, right? So the base station is designed to handle a fan out of maybe several hundred cell phones being connected to it, right? Your application could be different. There could be a different density that is required, right? If you are considering, say, for example, a street light application where the street lights are all in one line, right? It's a very linear topology that you are considering, right? Whereas other applications may take a more meshed approach, right? So my point here is that there are a lot of new radios that have come out, and and these radios have come out because they were designed for specific purposes. And when you are building your IoT application, when you are building that architecture, it gives you that flexibility, right, to make that choice. You have various levers in your control that you can tweak and turn in order to arrive at what should be the best option for your application, right? The last thing I mentioned over here was the density and the fan out, and that kind of leads to several deployment topologies that are available, right? The star topology, very, very popular with cell phone kind of applications. All your phones connected to one base station, right? Or you could have, as I said, a linear topology that is present in, say, for example, the street lights. Or you could see some kind of a hybrid in between, right? You have a core network of base stations, and you have other nodes that are kind of connected to, connected to at least one base station over a one-hop connection. Or you could just throw everything out of the window and create a complex mesh network, like the internet is, right? The internet is a complete mesh, right? So that's why you have different deployment topologies that are available, which will affect the kind of network or the kind of radio that you choose to use in your application, right? If we move forward, when you think about using your computer, if you want to say, for example, you want to shop on Amazon, right? You open up your browser, you go to Amazon.com, right? And you want to look at the things that you want to buy, right? When you are doing that, you really do not think about how you were able to get that data from the picture of that particular new laptop that you wanted to buy. How did that picture come to your screen, right? And that's why we don't think about it, because with computer networks, with evolution in computer networks, we have been able to create a communication abstraction, right? And this is what we popularly call as the OSI stack, right? There's the networking layer, there's the internet layer where we have an IPv4 or IPv6 address. We have a transport layer, which is based on either TCP or UDP, and then we have the application layer, right? And your web applications are sitting on top. So it is two your Chrome client that is talking with a web server on the other end, right? And the information is getting the underlying layers are kind of transparent to us. Oh, somebody had asked a question, what is triangulation? Triangulation is essentially when you can specify your distance from 3 points, right? You will always be able to certainly pinpoint where your location is with reference to those 3 points, right? So when we look at our mobile apps and we get a location coordinates, we are able to do that because we get signals from at least 3 GPS satellites, right? We use that information and create our own reference point out of that, right? So that is what triangulation is, right? Coming back to over here, in terms of this communication abstraction, the internet runs this kind of a stack. But just imagine what would happen if I run this stack on an embedded device, right? The moment you need to have a TCP stack, right? The moment you want to run TCP, you are expected to keep a session alive, right? And whenever you're keeping a session alive, which means that there are going to be these keep alive messages that go between the server and the client. If this was a battery powered device, it means that the battery has to be the device has to constantly stay awake, switch on its radio and keep sending ping pong messages back and forth. Which means that if I am going to run TCP on an embedded device, I am going to lose power very, very quickly, right? So it is a very difficult proposition to run a full TCP session, a continuous TCP session on these embedded devices, right? So clearly, embedded devices, I cannot run this kind of an expensive stack because I do not have the resources. Sometimes I may not even have the resources to decode a whole IPv6 address on one of these embedded devices. Therefore, what has happened is we have been developing our new IoT stack, which is meant for these embedded environments, which is meant to operate in these constrained environments, right? Where you see that you have lower level, radios that we had discussed earlier, right? Derivations of that 15.4 ultra wideband, or whether it is 802.11, the next generation of Wi-Fi technologies, all of them are coming in this physical radio form, right? And then you have, instead of the internet routing, we have a 6-LoWPAN, right? Which is a reduced form of, which is a simplified representation of the IPv6 addressing, right? Which ensures that there is unique addressability within the local network, right? We cannot use TCP, so we use a lot of UDP, right? We cannot use TLS and SSL kind of security, right? Because we cannot essentially compute those cryptographic keys so soon, right? So we use something like DTLS. We cannot use HTTP, so we use MQTT or we use CoAP, which are publish-subscribe models, right? We cannot use XML or HTML, so we use different data representations like JSON or binary. So the entire stack is kind of optimized for devices which are running low on power, right? Or they do not have sufficient computational capabilities, right? So that's what we have to do in order to build the IoT stack, right? And several protocols have emerged over here, like lightweight M2M, right, which govern how these devices can be managed, right? How their device management can be managed, right? This is done by lightweight M2M is a protocol that is 1M2M, right, which also governs a lot of 5G protocols, a lot of the telecom protocols, right? Because there has to be consistency in the way the data is transferred, so that interoperability between different devices Sorry, I got disconnected.
Yes, sir. No problem.
Sorry, I got disconnected. What I was saying is, if you are using your, for example, your modem at home, what you will find is you can easily log into 192.168.0.1, and that will open up your configuration page, right? The fact that it is opening up a configuration page means that there is a web server that is running in the device that is able to serve you that HTML page, right? Or if you have a smart, one of those smart lights, you could download an app, and the app could connect to the field device, right? So what is happening is that the user interface is now getting decoupled from the device itself. You can configure the device using either a field gateway or over the internet, or using an app, right? Which means that you can see the screen. The moment you're able to see this page, you can see this page over the local network, and with some additional modifications, we will see how this page can also be viewed from an external network, right? This is over the local network because you have to be connected to this device, right? Just like you can configure your home modem only when you are connected to that modem, you cannot configure it over the internet, right? Because the access information is not made public, right? So that is another innovation that is happening with respect to decoupling of the user interface, right? The other thing that has happened is With these devices, because they are now connected over the internet, you are starting to consider how do you manage these devices. So the gateway devices now have to take into consideration different forms of management information that it has to handle, right? For example, it could get an update on the models that it is running, or the kind of control messages that has to be handled, right? Or it could be a configuration message that has to change, or like you use your when you use your phones, you're familiar with being able to update an app on the phone, right? So you can have an application updates, or you can do a partial application update or a patch that can be done. Now, those of you who have experience with Android, you know that with when we were using APKs, you essentially bundled multiple forms of an app for different underlying hardware platforms, right? Nowadays, you don't do that. Now you patch because you detect which hardware the client system is running, and you give them the executable for that particular processor, right? Rather than giving them the big APK bundle, right? So and sometimes you need to do a complete firmware update, right? Your app plus OS, everything put together, right? With all of these, from a hardware perspective, from an embedded systems perspective, you have to understand how to manage all of that, right? When you are getting a complete firmware update, where are you going to store that firmware, right? Are you going to have a golden image that just in case when your firmware that did not boot up, can you go back to your golden image? Or can you have a delta update in place, right? Which means that you bring in only the changes rather than changing the whole operating system. If you are bringing in the whole operating system, how do you create a separate partition where the system is going to be kept? And how are you, if you are unable to boot up, how do you recover from the previous setup that was there, right? So from the IoT experience, yes, IoT is about these devices being able to access the sensor data from all these devices, but you have to understand that IoT devices are also networks, right? And the moment they are networks, you have to have complete control over those devices, right? So yeah, you cannot ship out devices and expect that there will be no firmware change on those devices ever after. In fact, you have to be prepared that there are going to be changes. And just like we are able to manage billions of cell phones, right? We have evolved those systems, those device management systems to manage billions of cell phones. We are evolving them even further to manage hundreds of billions of IoT devices down the line, right? That's where device management comes in. Very, very important aspect of IoT, and many of you can consider doing projects around this area for your to meet your undergraduate requirements. Not just we should be able to manage the network, right? We should be able to now connect the data, right? Connect the data from the field devices through this IoT gateway to the rest of the cloud, right? Now, it was very easy for me to say connected. The question is how, right? How do I connect my gateways to the application backend, right? And this is where there are multiple connectivity architectures that are available for the field gateway to connect to my cloud servers, right? And there are several internet access mechanisms that are available. Of course, the easiest ones is if you're connecting over Wi-Fi or over a LAN port, right? We know that this is how we are connecting our laptops. This is how we connect our desktops. So we know that this is how we can also connect to the internet, right? What other options are available to us? Well, we definitely have 4G because cell phones are connect to the internet like this. So if I can put a SIM card, I can get a IP address and I can connect, right? Or this is a slightly twisted architecture, but yeah, what if I connect my field device to my mobile app over a Bluetooth connection, and then use my mobile app, my mobile as a router, right, as a bridging device. In fact, my network is so bad now that I am using my phone network to give this talk now. right? So that is another way to connect to the internet. Also, there are service providers who are providing managed IP low power radios like Sigfox or narrowband IoT or LoRaWAN. Narrowband IoT is essentially where a lot of the 2G infrastructure is being recommissioned to for M2M and for machine to machine and IoT devices. So once you get onto their network, these networks provide a IP link and it is able to access the internet through that, right? So there are multiple ways, but the LAN and the PAN technologies, the low power radio technologies, they kind of sit over in this part of the network, and the field gateway has to have some form of IP connectivity or internet connectivity so that the data can go out and connect to the rest of the world, right? So we are evolving in our IoT device capabilities, right? And if it has to be AIoT, if AI has to be involved over here, then we certainly need the ability to do dynamic rules, or we need the ability to run models within this embedded system, right? And that is where we want to have a module which does this, if this, then that kind of a block. Right? If this, then that is a rule engine essentially. What we want is a dynamic rule engine so that we can choose where the connection is coming from, what are the input conditions, connectors that are there. Instead of specifying a rule in hardware or in the firmware itself, we want the mechanism to run these rules, right? We want a mechanism to manage those rules, right? So creating a rule, deleting a rule, updating a rule, managing an entire rule database, and having an entire evaluation environment, right? So either as a virtual machine or as a as a overloaded function, right, where I can now give it multiple parameters, and that way instead of specifying which rule to use, I will or instead of putting a rule as a precondition, I will pick the rule dynamically based on what my inputs has coming. For example, if I am going to compute a particular model, right? If I have a camera and I am doing object detection on that camera, and today I'm capturing the number of I have a model in there to recognize people, right, and do a people counting application. I should be able to push configuration change and give it a new model for recognizing cars, and I should be able to get a car count from that same device, right? So that's the difference, because now I can push changes, I can push new functionality onto these devices, right? Which means that when I'm evaluating a particular rule, what should be the action? Should I glow a light? Should I switch on a relay? Should I send back a message? That also should change, right? The input and the action that has to be done, these are all dynamic now, right? If they are, if I have the mechanism to make them dynamic, then the device management platform will help me push new configurations and change the functionality of the field device dynamically, right? That's the change that is happening. And this is getting recognized by pretty much all the silicon vendors, right? Which is why you will find that there are new edge processing chipsets that are coming out from pretty much all the major vendors, right? If you look at Qualcomm's Cloud AI or MediaTek's Dimensity, right? Or Samsung's Exynos, these have dedicated, these are mostly targeted towards cell phone kind of applications, but they're also being used in the for edge computing, and they have dedicated cores for object detection, right? For number crunching, right? For display drivers. So each of them are coming up with a specialized hardware with dedicated areas for essentially doing some of the AI work, right? With neural networks kind of made in hardware. NVIDIA has at the edge itself, right? So clearly, the Semiconductors are thinking that edge computing is going to be the next area of focus. Not all data actually needs to go back to the cloud if we can do a significant amount of the computation on the devices itself. And this again is a trade-off between what is the cost of each of these devices going to be versus the benefits that they are going to bring to the market, right? A number of these chipsets are RISC-based architectures because what we have found is that with RISC-based architectures, the power consumption is significantly lower, right? And the performance trade-offs that you have may not be justifiable, right? For example, Apple in its next generation of processors, it's already starting to run on RISC processors, and compared to a similar powered or similar computational capability Intel processor, they are clocking at about probably at about 20 watts of power. Some of the newer MacBooks and all, they are clocking at about 20 watts, whereas a similarish Intel-based system is probably clocking at close to 125 watts, right? So significant reduction in the energy consumption of these RISC-based systems. This is going to continue. The evolution for learnability is going to continue on these devices. And down the line, what we expect to see is there being a lot more context awareness, devices talking to each other to understand what is the context of a discussion that is happening, whether it is multi-data type fusion, whether it is in-network data fusion so that all the data does not have to go back to the cloud, or it is energy aware forwarding. So these are all in the realm of research areas that are also being explored, and we hope that this will lead to a better intelligence among the devices themselves, where they will start coordinating among each other, right? And that is why there is a long way to go. Even though we say that our devices are becoming intelligent, there is still a long way to go in this respect, right? They're not humanoids. They are humanoids. They're not human context sensitive aware yet, right? But they are definitely getting there. What does it mean for you? Again, let me go back to that fundamental question, because you're all in the session, we are having this discussion. It has to be, it has to boil down to where your opportunities are, right? And you have to understand that fundamentally with IoT-based systems, right, unlike other systems which are more vertical in nature, for example, many of you are doing maybe a web development stack where you have heard of a mean stack or a MERN stack. With the IoT technology, it is a horizontal stack, right? There are several devices that are that have to be taken into consideration when you are building an entire IoT workflow. And when you are building this horizontal workflow, you have to really pick what you want to specialize in. Whatever you want to specialize in, there is a role for you in this IoT ecosystem, whether it is on the device part and you enjoy writing the C APIs for this device drivers, or you want to build a CoAP API for the devices to talk to the gateways, right? Or you want to build an MQTT API or build the device management applications over here, right? Or you want to build simulators, or you want to build mobile apps and user interfaces, right? No matter where your internal inclination is, build on that, right? There is a role for each and every one of you, right? That you can do something that you are passionate about and find a resonance in at least one area of the IoT technology stack. Because you have to understand that, yes, IT is something that is growing. IT is, it was at about $600 billion of IT services in 2019. That is going to grow to about 1.1 trillion by 2025. But with IoT, It's at about 212 billion in 2019, expected to grow to about 1.6 trillion by 2025. So there is the managed services in this entire IoT ecosystem is expected to grow at 30%, right, rather than the 8% that IT is growing. When the industry is growing, right, you are also expected to grow along with that in the industry, right? You get the first mover advantage if you're building IoT projects. Of course, the compensation levels could be very significantly higher, right? There is the ability to grow inorganically because the startups are going to grow much, much faster than larger established companies. You have the opportunity to do some really disruptive work, right? You have the ability to work in core areas. Right? So all of this put together, IoT is really an emerging area to create new job opportunities, right? Based on your technology fitment, right? You build your skill set, whether you want, as an embedded engineer, you want your skill set to be more focused on the embedded side, or you want to have some amount of control over web development capabilities or mobile app development capabilities, that is fine, right? You choose where in the spider graph you want your skill set to be. And based on that, there are a lot of recruiters who are you can apply to, right? Either it is in the semiconductor side or the connectivity side or the cloud providers, right? Or the solutioning companies. All of these companies have operations in India and in many of them in Bangalore itself. They're all multi-billion-dollar organizations, right? So make yourself ready for something that is going to be relevant to these organizations, right? If you enjoy working for, if you feel that these are companies where you will be able to grow in your career, right? So rather than, there is definitely the channel of going through the campus placements and all of that, but you should also be trying independently, right? If you have done a good project, right? Now remember, if you have, if you are going to try for off-campus placement, the companies, they do not have any provenance information about it. They do not have any useful provenance. They do not know what kind of a project you have done, how effectively you have done your projects, right? That is why there is that barrier to entry as a fresher. But if you can prove otherwise, if you through your project demonstrate the challenges that you have faced, the maturity in your thought process, right? Your the complexity that you have handled, then there is no. I am at least convinced that companies will not reject you, right? They will expect you. They will hire you based on the kind of projects that you have done. You also, by doing a project, you also get a feel that if it is something that you want to build your career in, right? If it is something that you want to possibly even build a company out of, right? And you can also look into the startup realms, start your own companies right out of college, right? There's going to be a lot of support for innovation, a lot of funds that are being made available through the National Innovation and Startup Policies by setting up, institutional incubation centers, right? And that is something where you can also look at as an alternative career as well, right? So that's all that I had to pretty much cover. At Capsule Labs, we do offer a lot of foundational certifications, right? Mostly around IoT. You can check out our website for details on those, on what are the kind of certificates we provide, right? And pretty much, I think that's about it from the talk perspective. I want to summarize today's discussion by saying that, look, from an embedded perspective, there are developments that are happening on the sensor side. There are significant developments that are happening from the data acquisition side, on the low power compute platforms, on the uplink technologies, on the IoT protocol stack, and the MQTT and these kind of applications which address the problems of server role reversal, right? We'll not go into the details of them, but I hope I have been able to kind of give you an overview of what is happening, what are the fundamental innovations that are happening in the embedded space for IoT, right? And I think with that, I will take questions.
Yeah, students, if you have any questions, you can ask. You can unmute yourself and ask or put in the chat window.
Okay, the attendance form we have also not the attendance form. I think the feedback form Professor Anna has already shared. Right, we have shared another attendance link, and that is used for essentially creating your certificate for participation.
Yeah. Students, please fill both the attendance sheet as well as the feedback form. So the attendance sheet will be used for providing the certificates, and the feedback form is used for our documentation.
Right, so lots of young minds raring to go out there, right? At the verge of becoming engineers entering the workforce, right? So we have to build a better place. We have to build more powerful applications because nobody else is going to build them for us, right? Because the kind of projects that you pick up now, I think they are going to play a very strong role in shaping your career down the line. More often than not, this question will pop up as to what are the kind of projects you have done. If you have worked in a company, then the discussion is usually about the kind of work that you have done and your experiences over there. But use the next 6 months, 1 year to kind of work that out. When we did our projects, we made the mistake because we started coding from day one. We went to our faculty members, we asked them, if this is the project that we could do. The professor said yes, and the next day we got our friends together and started coding, right? Now, naturally, what happened was 2 months down the line, nobody had an idea about what is it that we are coding for, what is the objective that we want to fulfill. And when we picked our team, we picked it based on our friendship. So we didn't know if we had any complementary skill sets, and there was no communication plan. So 3 months, 4 months down the line, the project is in a mess. Everybody wants to do their own thing. And what is getting developed, there is no documentation about it, right? So needless to say, those projects did not go down well, and pretty soon it was time to submit, and we just submitted something, right, which was very different from what we had originally envisioned the project to be. My very strong advice is don't go down that path. Always first define the goal, define the project that you want to do, define its scope, and if you are defining its scope, you will understand what is the acceptance criteria for that particular project, right? And that will allow you to build its architecture, right? It will allow you to plan the test cases for that application, and then you start your coding work, right? Then you start developing the project further, right? That way, at least you will have some control over the complexity of the program, right? Should something go south, should something go bad, you can change that. You have the visibility in order to address that early on in your project, right? So the project is going to play a very, very important role, right? Any questions? If not, then I think we can go ahead. So Bahul has asked, what effect will IoT have on our daily lives? Your life changes depending on how you are using IoT. There is a significant amount of change that has already happened, right? For example, when the question is similar to saying, how did the mobile change your life, right? Well, you are now accessing a lot of things on the mobile itself. A lot of productivity in factories are changing. They have become faster and more effective because you are implementing IoT based because you have implemented IoT in the production lines itself. Your ability that you are tracking your food as it is getting delivered, things like hailing a cab online, right? So these are all essentially IoT based systems, right? So comfort and convenience from a consumer IoT perspective, operational efficiency from an industrial perspective, right? And better government services from a government perspective, right? Does that answer your question, Bahul? Right? Any other questions?
Yeah, thank you, sir. Thank you so much. It was a wonderful session where we could know about what are the developments happening in the embedded technology and IoT, and also about how to build AIoT devices, and what are the new job perspectives in the IoT domain, and how to carry out projects in the embedded domain. So we look forward for future interactions with respect to the projects. Thank you, sir. I now request Abhinav, sir, to give the concluding remarks and the vote of thanks.
Mute. Hello, am I audible?
Yes, sir, you're audible, sir.
Yeah. Thank you, sir. Thank you so much. Thank you, sir. I just would conclude this webinar. I just want to say some few words. Yeah. I would like to thank our guest, webinar speaker, Mr. Atanu Roy Chaudhary, for the virtual visit and enlightening us with your knowledge. Today's webinar was full of knowledge and interesting facts. Yes. It gave us deep insights into the topic. I'm pretty sure the knowledge which was shared by Mr. Atanu will definitely help the students for carrying out their future projects. And if they are going into research, that will also certainly help us. Thank you, sir. Thank you very much, sir.
Thank you, Atanu Roy Chaudhary, sir. Thank you so much. And we will be looking forward for more collaboration, few lectures like this, sir. Thank you so much, sir. Students are very happy, and they were telling, sir, such type of lectures are required for us, sir. Thank you so much, Atanu, sir. It was an
great. I hope this was useful. I hope this was useful for the students.
Absolutely, sir. Absolutely, it was absolutely useful, sir. I mean, the students are calling me and telling, sir, it was a superb lecture, sir. It was. They're calling me and telling, sir. They're sending me WhatsApp messages and telling. And
yes, sir, definitely.
From such an experienced person, so definitely I told them it is going to be good. And they're telling, sir, even though being a Saturday, actually Saturday is holiday for students. We are working, but Saturday is so even though they say we had logged in and we got a very good knowledge and update on what is happening in the industry and what is.
This is the first in a series, so we will look at similarly how do you not only build from a devices perspective, right? You also have the ability to scale up your machine learning skill sets, your web development skill sets, right? You can do a lot of things around IoT. So we'll cover them in future sessions.
Sir, and a big thank you from our student side also. All of them are saying thank you to you, sir. And all are very happy, sir. Thank you, sir.
They're all more than welcome.
Yes,
it was really exciting to share.
Great help to student community and further to society and to our country, sir. Thank you so much, sir.
Thank you.
Have a nice day, sir.
Yes.
Have a nice day, sir. Thank you so much. Thank you, Abhinav, sir.
Thank you, sir. Thank you, sir.
Anna, ma'am, thank you, Abhinav, sir, for arranging this wonderful lecture. And Anna, madam, thank you.
Thank you, sir.
For all your back-end support. Mukti, madam, thank you so much. Thank you so much. Have a nice day, all of you. Happy weekend.
Please
Stay
fill the
healthy.
feedback form as well as the attendance sheet.
Students, please fill the feedback form. It is useful for you. It is you.
So you have to fill both the links, the feedback form as well as the attendance sheet. There are 2 links, so both of them you have to fill it. So one will give you the attendance and other one is for our documentation.
Bye, sir. See you. Thank
Yeah,
you.
thank you, sir. Bye.
Thank you, Anna ma'am. Thank you, Mukti ma'am. Thank you, Abhinav sir. Thank you, my dear students, for joining. I'm logging out, ma'am. Is it okay?
Yes, sir. Yes, sir. Yes.
I think you can stop recording now. I think.
Yes.
I think. Thank you, Abhinav sir. Bye. Thank you, sir.
Thank you. Thank you. Just stop recording. And end the session.